Okay. This is my second time doing this video because I left something out in the last one, and also it was like this, like you couldn't really see what I was doing down here. So, all right, here we go again. So, again, we have a pretty simple problem. Just remember fixed attachment to a wall so it doesn't move. And the only thing that we have on it is this force here labeled P. I'm not working with numbers again, just so we kind of get the general idea of how this works before we put some numbers on it. All right, so let's do it. We just have this force here, P, and thing about forces is they create moments on fixed joints like that, right? Because this force here is trying to rotate the bar that way. Like if this could move, it'd go like that. So we need something to oppose it going that way, right? So that's the direction that our moment's going to be in over there. Great. Now we also need a reactionary force over there because forces have to equal 0, right? So label this A and B. We're going to have a reactionary force A in the Y direction there. So RAY. And technically we'd also have an RAX like that, right? Because it can't move this way either, but since there's no other forces acting in the X direction in this system, we can assume that that is 0. Okay, and this is A, moment at A. Sweet, so again, I start my problems by summing the moments. So I'm gonna do a positive sign convention there to be counterclockwise, and sum the moments, they equal 0, right? And that equals moment at A, and it's positive, right? Because it goes in the same direction as my convention there. And then the moment that creates, which would be, or sorry, no, not plus, minus, right? Because it's going against, this is where we're concerned about, and that's going against my positive sign convention, right? That'd be going clockwise, it's counterclockwise. So minus P times distance L, right? Force times distance, create this moment. All right, so solve for MA equals PL, great. I start with the moments. I start by summing the moments because a lot of times it'll give you forces that you need to start your shear diagram. Put those on there. But in this case, it doesn't really, so it didn't really matter. But here we go. Let's sum the forces now in the Y because there's only forces in the Y. Equals 0 equals positive RAX, right? Or sorry, RAY. What am I saying? Because, right, it's going up, so it's positive. And then minus P, because it's going down. Solve for RAY equals P. Which we could have also guessed that because the forces need to cancel out, and there's only 2 of them. So, time to graph the shear, right? Forces create shear. So, working left to right, what's our first force? RAY, right? And RAY equals P, so it's going to go up a magnitude of P. And then from there, nothing happens, nothing happens, nothing happens until here. We get another force, right? And it's P, but this time down. So it's going to go back to 0, which is great. We need them to end up at 0. That's very important. Always make sure they end up at 0. If not, then something went wrong. And I shaded in just, make it looks nice. You can tell where the axis is better that way. All right, so now time to do the moment diagram, right? So we start with the moment at A, working left to right, and there's no other moments along the rest of the thing. So let's put that on there. We are starting with moment at A, and even though I said it's positive when I'm doing the calculations, this is negative bending moment, right? Because of the frowny face. See? And this is that there. Frowny face, negative moment. So we're going to start down here, right, instead of up here. And the magnitude is PL, because MA equals PL. Put that there. And then there's two ways to think of it from here. Either you just know that there's no other moments, so it's going to just go straight back to 0, just like that in a line. Or you can think of it as it needs to, the slope of this line, or like the amount that it goes up the value of this area, right? So this magnitude P times the length L will get you, right, P times L. And if we see here is P times L, so then we got to go up P times L because this is positive, right? If this was below the axis, it would be negative and we'd be going down. But it's above the axis, so it's positive, and we get to go up straight back to 0. Whichever way you want to think of it. I think the second way is technically like the more correct way of thinking of it, but you could also just do 2 inspections, see that it will go straight back to 0 because there's no other moments acting on it. All right, see you in the next one.